Hello, ladies and gentlemen. My name is Eva Kelesidou, and I am a senior claims handler of the Standard P&I Club. I am also a member of the club's Alternative Fuel Working Group representing Greece. The Alternative Fuel Working Group is closely working with an advisory panel of external key professionals of the industry. We are monitoring the developments of decarbonization, we are sharing knowledge, and we are advising members, the club membership, through the energy transition. Today, we are here to discuss spillage response and alternative fuels. It is almost impossible when we are talking about spillage response not to think of our partner within the shipping industry, ITOP. ITOP, who, for those who are not very familiar with it, is a not-for-profit organization funded globally by the shipping industry. ITOP, the last 50 years or more, has responded to a significant number of spillages around the world. Members of ITOP technical staff are increasingly called upon to respond to spills of bunker fuels, chemicals, and bulk cargoes from all types of ships. Joining me today in this discussion on spillage response and alternative fuels is ITOP Technical Advisor Andrew Lemazerier. Andrew is an environmental scientist with significant experience on spillage responses all around the world. He has also provided multiple presentations on the topic and training workshops abroad. I wouldn't miss this opportunity to mention that we have the privilege of having Andrew in our club's advisory panel of external professionals. Andrew, we are very happy to have you here today, and thank you for being a valuable and active member of our advisory panel.
Thank you very much, Eva. It's a pleasure to be invited, and it's a very important forum to discuss the sort of future alternative fuels and any spill implications there may be.
So, Andrew, this is the hot topic nowadays, and actually a very important one. Would you be happy to share with us what is your experience with incidents involving alternative fuels?
Yeah, so alternative fuels, as you said, are not sort of widespread yet commercially. And so the industry does have a limited experience when it comes to incidents of these types. I mean, one new fuel that may be worth mentioning is low sulfur fuel oil, and ITOP has attended 9 incidents involving these and provided remote advice with many more. Now, just briefly to discuss this, one sort of key aspect of this fuel type is it's highly variable, and its chemical characteristics differ, and therefore its fate and behavior differ when spilled in the environment. What we found is in warm waters, such as spills in Mauritius, Gibraltar, and Greece, we found that the oil is less viscous and penetrates deeply into sediment, whether that be mangroves or riprap. And this long-lasting low viscosity means that the oil is readily remobilized frequently, which does have sort of spill implications. But one good aspect of this is that low pressure flushing is a good technique to clean the oil up, and we found that especially in Mauritius. But then on the other hand, in cold waters, we found that there was a spill in Sweden, and the water temperatures were lower than that of the pour point, and so the oil turned into semi-solid globules, which sort of persisted over time and traveled great distances, over 150 kilometers along the coastline, and ended up polluting the waters of neighboring Norway. And so that is also something that needs to be taken into account. So it's very highly variable, which is one of the things that we've seen over the past 2 years since its sort of widespread implementation. But as for the alternative fuels we'll be discussing today, ITOP has some experience with biofuels or biofeedstocks, namely vegetable oils, and we've responded to 3 incidents in the world, in China, Chile, and Italy. And so we do have some experience of that. But today we haven't been involved with an LNG incident at the moment.
So would you say that those oils behave in the same way as conventional fuels, and are they perhaps easier or more difficult to handle with?
So they differ. So for instance, the 3 sort of straight vegetable oil spills that we've attended, the oils have solidified upon impact with the water. These were palm oil spills, mostly, and they form sort of plates and lumps up to about 60 centimeters in diameter over a relatively concentrated area. So there's a slick of sort of these solid materials. And then over the next day, the solidified globules sort of break down slightly into smaller pieces, and they form like a belt or a slick, that moves under the influence of the sort of prevailing weather conditions, so current and wind conditions. So when it comes to ease of cleanup, they use a lot of sort of rudimentary techniques we used, and they were seen as quite useful. So fishing nets, basically with the main way of collecting these sort of solid oiled substances. So that was easy, and then there was shoreline impact, and amenity beaches in the area had to be closed, but the impact was lessened because, again, it sort of the oil remained solid, and so it was easier to collect using manual techniques, and so that way it was easy to clean up as well. And another sort of nice part of it was that more than 50% of the oil that was recovered was able to be made into biodiesel, eventually after that. So that's a sort of good story regarding that. And then biodiesel, which is the sort of the main biofuel that is being discussed, is it very interesting because it's highly variable depending on the blends, or the additives that are used, or the feedstocks. And as biodiesel is chemically different to petroleum diesel, it's more readily metabolized by bacteria, and so it biodegrades faster and is therefore less persistent on the water surface. However, this does come into a negative impact in the fact that because these microbes are breaking down the oil so much, it can displace the oxygen in the water, which can lead to sort of short-term local sort of ecological impacts. But yeah, that's what we've experienced with biofuels.
You mentioned also earlier LNG. As liquefied gas, it must behave a bit differently compared to the petroleum-based fuels. Is this correct?
Yes, yeah, you're totally right. It has significantly different properties. So LNG is, yeah, as you said, liquefied natural gas, and it's predominantly methane. So LNG has a specific gravity of about half that of water, and so if it were to spill in water, it would float. And as it's stored cryogenically, I think it's stored less than minus 160 degrees Celsius. If a breach were to occur in, say, the fuel tanks or something, and the product were to be released into ambient conditions, it would vaporize, as sort of as it touches the sort of warmer ambient conditions. And so if it was spilled on water, this vapor would, when it vaporizes, a vapor cloud would form, which could move laterally on the surface depending on atmospheric conditions such as the wind. And as methane isn't highly soluble with water, it means that the methane won't be lost to the water. It wouldn't, there's be minimal dissolution. It would sort of not have much interaction with that. Another thing to take into account is also during the vaporization, any moisture in the air would freeze, which could lead to like a thick fog. So when there are LNG spills, it's sort of that is what's noted, a thick fog, which can have obvious sort of response implications. And that also has LNG also has the sort of capacity to displace oxygen in the air, which could cause suffocation risks to seafarers, responders, and bunkering operators and things like that. It also is worth noting that LNG is flammable when vapors reach between 5 and 15% of the atmosphere.
That's also very interesting. Well, if LNG mostly evaporizes and is not persistent in the environment, would you say that the response spillage may not be necessary or that the impact on claims might be less heavy?
Well, yeah, not necessarily. I mean, as we've seen, it's as I've discussed, the impact is going to be short term. So as it vaporizes and it'll be rapidly sort of lost to the atmosphere, and so you're not going to see a long term protracted spill response like you would for a conventional oil. It may be that the response is just adapted in a way. So it may just be sort of monitoring that takes place and maybe atmospheric modeling of where that plume is going to travel. So, for instance, if an incident is happening near a very populated area, then it may be that the response is looking at where this plume could be that could be explosive and it could displace oxygen and see if there are any sort of sensitive receptors in the area where there maybe need to be evacuations or things like that. So that's something that could be taken into account. And then also because of the sort of the way that LNG is stored, if there was an incident, there could be cryogenic damage to the vessel, and so sort of salvage will be involved as well, and that's something that else needs to be taken into account.
I think you have explained in a simple way the differences that biofuels and LNG may have in comparison to the conventional fuels. With this in mind, would you please share with us your thoughts as to the claim trends in the future? What should we expect? What type of claims should we expect mostly, in your opinion, and whether you foresee that those claims are going to be more expensive?
Yeah, so when it comes to expense, I may not be able to comment wholeheartedly on that, but the sort of claims implications of biofuels and LNG are most likely to be significantly different. So for biofuels, you're going to probably be seeing a similar sort of trend as you do now with conventional oils, and sort of these would include cleanup and preventative measures, which are probably similar to what you'd have with conventional oils, albeit the cleanup may be a bit more simple if it's less persistent on the water surface. And then you'd also likely to see that the property damage, the economic loss, and the environmental damage and post-spill studies claims that you'd normally see with oils. And then for LNG, it would be drastically different. So the claims may be sort of related to a short-term catastrophic incident. So if there was a release and there was a fire or explosion, then you could be looking at loss of life. You could be looking at property damage to, for instance, if this was done during bunkering, then there may be property damage to the port structures, things like that. When it comes to environmental harm, the most likely sort of environmental harm for a LNG spill would be very short term, and would be maybe due to the local reduction in water temperature causing sort of deaths in the vicinity of the spill from or ecological deaths in the vicinity of the spill. But it's going to be sort of slightly different claims that you normally expect.
Andrew, this has been a really interesting and insightful discussion. I am really grateful to ITOF and you personally for sharing your experience and thoughts on the topic. I hope our viewers today have enjoyed watching and listening, and wish you a pleasant day ahead. Thank you.